All right, logicians, I want to talk to you about section 8G, where we are introduced to conditional proofs. Now, a conditional proof is a method that starts by assuming the antecedent of a conditional statement, and then it concludes to derive the consequent of that conditional statement. Then it discharges by proving the entire conditional statement. Let me show you this example here. So you're given these premises 1 and 2, and we're supposed to prove if P, then R. Now, I'm trying to prove a conditional statement. If P, then R. One way I can do that is through the conditional proof procedure. So what I do is first of all, you've got this upside down L that indicates you've got this indented proof sequence. Now, I don't know how to reproduce the upside down L in like my Word documents, but I do indent them when possible, or otherwise indicate, okay, this is an indented proof sequence. It needs to be set apart as its own kind of little world. So, but ideally, you've got this upside down L and you indent it. The first line of the indented proof sequence is the antecedent of the conditional that you finally want to prove. I'm sorry, yes, the antecedent of the conditional you want to prove. So it's the P. And the justification for that line is assumption CP, conditional proof. Now, you can assume, for the sake of argument, anything you want, you can put on the assumption line. At the end of that proof sequence, it's going to be the antecedent of a conditional statement, but you can throw in anything. Now, once you've introduced that, then your goal is to prove R. And you can use, in order to prove R, you can use anything that's outside the proof sequence or anything that's inside the proof sequence. So in this case, once we've assumed P, then we can use 2 and 3 to do modus ponens, and we get if Q, then R. Then we do another modus ponens, and we get R. Boom. We've proved what's going to be the consequent of this conditional statement. At that point, you end the indented proof sequence. The next line is outside of the conditional proof sequence, and it is the conditional statement, if P, then R. The justification for that is everything that is within the proof sequence, because you've proven, if you assume that P, then R must follow. You've proven if P, then R in that proof sequence. And the way that you justify it is you have 3 through 5. So you have, and that's a dash, by the way, it's not a comma, because you're saying everything in line 3 through 5 in that whole sequence by conditional proof proves that this conditional is true. Now, you could keep on going in your proof, because maybe that was just one line. You need to prove something else after that. That would be fine. If you did, you can't go back and dip into the indented proof sequence to prove anything outside of the indented proof sequence. It's its own little hermetically sealed world. It can reach outside and get other lines, but you can't reach back into it to prove things that are outside the indented proof sequence. So a few basic ideas here. You're going to use conditional proof when the conclusion that you need to prove is a conditional statement, because that's what it's going to give you. That's the only kind of statement it'll prove. Now, you might have a situation where, there might be multiple ways to prove a conditional statement. After all, different rules that will give you a conditional statement. Material implication will give you a conditional statement. Hypothetical syllogism will give you a conditional statement. There's other ways to do it. So conditional proof is just one way. There's going to be some cases, though, where none of the other rules are going to work for you, and you're going to have to use conditional proof. So bear that in mind. It's a special and powerful way of proving conditional statements. Remember, you can't use premises that are within the conditional proof sequence once you get outside the conditional proof sequence. And you can use multiple conditional proofs in the same proof you can even use them inside each other. And I'll show you an example of that. Let's look at some examples right now. Show you how this works in practice. Okay, so let's look at this first example. Premise one, if P, then not Q and not R. And we're trying to prove either not P or not R. All right, so as I think about that, maybe I muddle through a while and think, I can't figure out any way to get this. But I do notice one thing, and that is this final conclusion here, not P or not R, I could turn it into a conditional statement, right? Or I could get it from a conditional statement rather by material implication. So if I'm working backwards, I'm thinking about this, I might say, I'm going to get this by material implication from if P, then not R. And then that raises the question, well, how am I going to get that conditional statement? And again, let's say I rack my brain, can't think of any way to do it. And I say, I'm going to try conditional proof. All right, that means that the final justification for this conditional statement, it's going to be the discharge of a conditional proof. It's going to be like line 2 through whatever we get to by conditional proof. That means I'm going to start an indented proof sequence here. Pretend I'm under an upside down L. And I'm going to say, okay, assumption. And the assumption, the first line of this indented proof is going to be the antecedent of the conditional that I'm trying to prove. This is what happens to me. It drives me nuts. I'm just going to do it like this so it doesn't. I have troubles with the indentation. All right, so this is line 2. It's going to be P, and the justification is going to be assumption CP. Okay, and then what I know is that the final line of the indented sequence, whatever this numbering situation, the final line, I don't know what number yet it's going to be, is going to be the consequent right here of the conditional statement that I'm trying to get to. So it's going to be, I'm going to try to prove not R. Okay. So now I'm going to ask myself, okay, how am I going to get to not R from these premises? And I can see pretty easily how I'm going to do it. I'm going to do a modus ponens, and then I'm going to do simplification. So line 3 is going to be by modus ponens. I'm going to get all this stuff. It's by 1, 2 modus ponens. And then I'm already done here. I'm going to get not R out of line 3 just by simplification. And now that's where I needed to get to. So now I can drop out of the conditional proof sequence. We call this the discharging the conditional proof. And now I know that it was, I proved that conditional in lines 2 through 5 by CP. Sorry, 2 through 4. And this is going to become line 5. This is going to become line 6. And that's how I do it. Again, I don't have the upside down L, but I've indicated the indentation here. All right, let's do another example. And this one's going to be fun because we're going to do a conditional proof inside a conditional proof. You'll see why. All right, so here's my premise. If P, then Q and R. And I'm trying to get to this conclusion. If S then P, then if S then R. Whew. It's a mouthful. All right, so how am I going to get this? I think, well, I don't know. Let's try conditional proof. So if I do it by conditional proof, then, the first line is going to be, this whole conditional here is what I want. So the antecedent, I'm going to put it here. And then the final line of that conditional proof I have such troubles with the indentation. Whatever it ends up being, I need to get to this. And so this one, the justification for the final conclusion will be, lines 2 through whatever it turns out to be by conditional proof. And the justification for the first line is going to be assumption CP. Okay, so now I'm asking myself, how am I going to get from these premises to if S then R? And here's what I'm thinking. Like, I feel like, look, if S then P, if P then Q and R, right? So can't I say if S then Q and R, right? Isn't that like kind of the direction I want to go? Is that going to do me some good? Let's see. So I could say this, and I'll say, all right. By hypothetical syllogism, I'm going to get this. 1, 2, HS. Great. But how am I going to get if S then R? Like, I don't know how to do that. So I think, well, it's a conditional. You could puzzle over. I don't know how to do it. Maybe I'll do another conditional proof. After all, this is a conditional statement that I'm trying to get to. So let me see. Maybe I'll get it by conditional proof. So I'll start another indented proof sequence. How far in here to indent? That's indented, yeah. I'm going to assume S, and then somehow I'm going to get to R. Actually, it's going to be easy to do. Okay, now how am I going to get from S to R? And by the way, so this will be justified by assumption, CP. I have such troubles with it. All right, and this will be, the discharge of a conditional proof. So it's going to be 4 through whatever by CP. So, well, it's actually easy, right? Because I can just get R out of line 3 by simplification. There we go. So now I've got, antecedent, consequent, boom, discharge. I'm at line 6. This turned out to be line 5. This turns out to be line 7. This turns out to be line 6. All right. So you see how that worked? I did, I've got a conditional proof. And within that conditional proof, I had this little conditional proof. And I discharged it, and then I discharged the bigger one. So yeah, that's how you can have one inside another. Now in our next unit, in 8H, you're going to learn about indirect proofs. The same thing goes. Indirect proofs are another kind of indented proof sequence, and you can also nest those, and you can nest indirect proofs inside conditional proofs and vice versa. So all of that is fair game. Just remember, you can't dip back into an indented proof sequence once you get outside of it. Just remember that. All right, there you go.